Modern IT teams face a constant tug-of-war between performance and capacity. As data grows more complex, it's no longer just about how much is stored, but how often it's accessed and where it lives. Critical workloads demand speed, while dormant data quietly consume space. Without the flexibility to adapt to shifting data needs, organizations are forced into an all-or-nothing choice: prioritize performance at a high cost, or optimize for capacity and risk slowing down what matters most. Recognizing these challenges, DataCore has introduced a groundbreaking capability in the SANsymphony: adaptive data placement. At its heart, adaptive data placement marries the capabilities of auto-tiering with inline deduplication and compression. This blend ensures data isn't merely stored, it's stored intelligently, optimally, and in a manner that guarantees peak performance without squandering valuable storage resources. With that in mind, let's dive into the demo. We have configured 8 virtual machines in the lab, with some running iometer to generate I/O on the disk pool. Let's take a closer look at the VMware infrastructure. Under Data Stores, we have a data store called VM Disks. When we click on this data store, we see that it contains 8 VMs, with 3 currently running iometer. The iometer gauge shows around 4,200 IOPS per second for all 3 VMs. This performance information is key as we start our demo of adaptive data placement. By understanding the current state of our VMs and their performance metrics, we'll better appreciate the benefits of the adaptive data placement process. Now, let's shift our focus to the SANsymphony UI. Here, you will find the VM disks where all the VMware VMs are hosted. Let's now click on the disk pool 1. We can observe that currently it is 50% full. Next, we will take a look at the allocation view, which currently displays only one tier, Tier 1, with all high-performance disks. To enable capacity optimization, we first need to do it at the server level. I have already enabled it, so I will leave it as is. However, it is mandatory to enable capacity optimization and assign disks at the server level first. After that, we will navigate to the disk pool settings, enable capacity optimization, and apply the changes. With capacity optimization applied at the disk level, we are now ready to move forward with the process. Next, let's go to the VM disks. In the settings, we will check the box for inline compression. Additionally, we can enable inline deduplication and choose to optimize stale data only. Here, we have various policies that dictate how the data is moved. Depending on the selected policy, the data will be migrated accordingly. For instance, if we choose the lazy policy, only 25% of all data will be moved from the high-performance Tier 1 to the capacity optimization tier, which is deduplicated and/or compressed. This process is always on, fully automatic, and operates in real time, ensuring cold data movement remains dynamic based on data access patterns. Understanding these options allows us to customize the optimization process to our specific needs. As we would like to get the most possible cost savings, for this demo we select the aggressive policy, that allows us to leverage the capacity optimization tier for around 75% of all data. If I navigate to the allocation view, we can begin to see the capacity optimization tier taking shape. You may observe that nearly 3 GB of data has already been moved from this pool to the capacity optimization tier. While this process is ongoing, let's check the VM disk and note that almost 24% of the data has been transferred so far. As this data transfer is happening, the VM's performance is almost equal to the IOPS values we initially noted. This demonstrates the effectiveness of adaptive data placement in maintaining performance levels even during data movement to the capacity optimization tier. Let's revisit the SANsymphony UI. I will speed up the video so you can see that nearly 75% of the data has been relocated, thanks to the aggressive policy chosen during the capacity optimization setup. Overall, about 278 GB of data has been transferred across the pool, resulting in a 32% reduction in storage space needed. The cold data, comprising roughly 3/4 of all data, is stored on much cheaper disks. Importantly, VM performance remains unaffected. In summary, the demonstration showcases how SANsymphony's adaptive data placement intelligently balances performance and cost across your storage infrastructure. Powered by AI and machine learning, it identifies stale and infrequently accessed datasets. Through policy-based automation, it dynamically deduplicates and compresses cold data, seamlessly moving it to lower-cost storage tiers, while ensuring that critical datasets continue to benefit from premium storage performance. This allows organizations to maximize storage efficiency and control costs without compromising on performance. This wraps up our demonstration of adaptive data placement. Thank you for watching.